An endoscope is a tube with optical glass fibers and lenses inside, attached to a video camera. Doctors feed the device into the patient, for example via the mouth or by inserting it through a tiny incision. They can then analyze the images that it captures from inside the body. The technique allows surgeons to see inside the patient during an examination or surgical procedure, with the optical fibers providing an ingenious way of shedding light on a host of medical conditions. To prepare the optical fibers, glass rods are suspended from the top of a tall oven, which heats them to 900 degrees Celsius. This melts the rods, which drip down to form thin strands. A guide wheel turns this glass fiber in a horizontal direction. The fiber is then wound onto a rotating drum that stretches it to a hair-thin diameter. Several single fiber spools are then combined on a large winding wheel to form a bundle containing thousands of fibers. To make the cable that will connect the operating room's light source to the endoscope, a bundle of fibers is inserted into a silicon cable sheath. This cable has 9,000 fibers. A stainless steel ferrule is then screwed onto each threaded end of the sheath. The inside of the ferrules and optical fibers are now coated with glue, before heat is applied to cure the adhesive. Any excess fibers are trimmed, before both ends of the cable are polished, which finalizes the dimensions and allows the light to shine through. An initial quality control test ensures that the fibers can withstand a prescribed amount of pressure without cracking. Spools of optical fibers are also used to construct the light transmission system inside the endoscope. To do this, a bundle of optical fibers is first cut to the correct length for the endoscope model being produced. Endoscopes vary in length and diameter, depending on the part of the body they're designed for. After verifying that the bundle is the correct diameter, the optical fibers are tied with string to hold them together. The fiber bundle is then inserted between the inner and outer stainless steel tubes that make up the main body of the endoscope. A stainless steel adapter is now attached to the protruding optical fibers. This will connect the cable from the operating room light source to the endoscope, transferring light to the optical fibers inside the device. The fibers are now inspected under magnification to check for black spots. These would indicate broken fibers, which would interrupt the transmission of light. An endoscope transmits an image much like a telescope. Optical lenses send reflected light, which produces the image from inside the patient, all the way to the surgeon's eye, peering through the top. The endoscope's lenses are made from glass rods. Once cleaned with a chemical solution, they're aligned in a fixture, separated by brass spacers of various lengths. An endoscope may contain 5 to 7 lenses, depending on its length, and the spacers create specific distances between them. Once the image transmission system has been assembled, it can be slid into the inner tube of the endoscope. An ocular cap is then screwed on to hold everything in place. The cap's glass top is cleaned before an eyepiece is attached. This gives the surgeon the option of looking directly into the endoscope or looking at a video monitor, which receives the image via a small camera attached to the eyepiece. The image transmission system is now given a quality control check using a test pattern. As this demonstration shows, once assembled in the operating room, the endoscope is secured in a fixture before a cable running from the room's light source is attached. The light travels through the endoscope, illuminating the area that the surgeon is working on. The lenses reflect the image to the top of the endoscope, giving the surgeon a perfect view of the operation. And that, folks, really is the ins and outs of it.